This is calculus 2. We're gonna study new concept. It is a power series. What do you learn so far? We learned the series, then we learn how gonna test if the series gonna converge diverse. We learn divergent test, ratio test, integral test, comparison test. Now I'm gonna introduce new concept of power series. So you guys really pay attention about this concept. Let's just start of geometric series we studied. So I'm gonna give one example. Here is a geometric series 1/2n. Another one is a geometric series 2 to the n. What is the ratio of these series? Are gonna be 1.5. This one is less than 1, greater than -1. You're gonna say this is converse. The second series, R is 2, greater than 1, this is diverse. So that's the geometric series, right? So I'm gonna put x in the ratio. So you're gonna see this series right here. Summation xn. X is unknown variable. X is variable we don't know. Depends on x value. This series might convert, this series might diverge. For example, x you put the 1.5. This series is converge. X put the 2. This series gonna be diverse. We call this one is with the variable, series with the variable, that's gonna be called power series. Okay, so you just get them some idea what you're gonna do in this session. Here is a formal definition of a power series. So when you see this power series, you have to identify a couple of things, guys. The first thing is, here is the first thing you have to know. What is gonna be center? Center is gonna be x equals c. Here is a center. Center gonna be, here is a center. That's represent center. And then this an is gonna be coefficient. So an gonna be coefficient, guys. An gonna be coefficient. So when you see this power series, x is variable, c is represent center. You're gonna expand the power series at x equals c. An is coefficient. So very special power series is gonna be center is gonna be 0. When your center is 0 right here, guys, when your center is 0, summation n equals 0 to infinity an, you plug in x equals 0, xn. So that's why you have n equals 0 to infinity an xn. That you're gonna have this form right here. When you plug in the right side, c equals 0, that's gonna be what? A0, A1, c equals 0, that's x. C equals 0, A2x squared. C equals 0, A3x cubed. General term gonna be an xn. So what do you see right here, guys? Look at this form is x is variable. So x is, we have find this series gonna be convergent divergent. That's we're gonna do later. But first, we just get used to notation of a power series. This is a power series. This is an example of power series, guys. So how do you know this is a power series? First, you notice here is variable x. Here is variable x. And here is a power representation. So I'm gonna start with this one. So general form of a power series, previous slide, we see summation an x minus c n power n equals 0 to infinity. That's the power series. So look at this one, summation n equals 0 to infinity, 1 over n factorial xn, right? So what is the coefficient an? An gonna be here 1 over n factorial. Here is xn, c value is center gonna be 0. That we identify this power series, okay? Let's go second part. How do you know this is power series? This is variable right there. B gonna be summation n equals 0 to infinity xn. So coefficient we wanna find an. So an gonna be each coefficient gonna be 1 and center gonna be 0. You clearly find that? If you can, you're going to expand this one. X0, X1, X2, X3. This one is going to be, if X0 going to be 1, X, X squared, X cubed. Coefficient represent this one is, here is A0. Look at this power, coefficient is right here in front of X. That's the 1, that's the A1. Power is 2, here is 1, A2. Power is 3, coefficient is 1, A3. So all the coefficients are going to be 1. That's I represent right here. Everybody make sense? Okay, let's have another example. Let's have another example, okay? Power series looks like this one, summation n equals 0 to infinity an x minus c to the a. Here is an coefficient related to power, guys. Keep in mind that one. So let's just start with this. How do you know this is power series? Here is x variable. So we're going to write this one, summation n equals 0 to infinity, negative 1 and n, x plus 1n. So first, let's find the center. Center going to be inside x plus 1. We have x minus c. So this one is x minus minus 1. So when you see number is 1, center gonna be opposite sign. So c is negative 1. What is an? An gonna be coefficient. Each power n coefficient is negative 1 and n. So let's clearly we wanna see reading coefficient of each term. So you're gonna expand this one, n equals 0. X plus 1 to 0. Look at the power. This one represents A0, okay? Power is 0, represents coefficient A0. Negative 1 and 1, x plus 1, 1. Negative 1 and 2, x plus 1 square, so on. Negative 1 and n, x plus 1 n, okay? So this one is A0. Negative 1 and 0 gonna be 1, so A0 gonna be 1. I want to using different color, guys. Look at this one. Here is A0 gonna be 1. This is power related to reading coefficient. Here is 1. This one gonna be A1. So A1 gonna be negative 1. Here is the power is 2. A2 gonna be negative 1 squared. That's gonna be 1. So all the way there, this is represent AN, coefficient. AN, that's going to be negative 1 and n. That's your identify coefficient, okay? Let's do this. Last example here is D going to be, look at this one, summation n equal 1 to infinity. I want to write down 1 of n, x minus 1n. What is the center? Center is identified. Center is 1 right there. This is a center. an gonna be here. That's coefficient, right? So an gonna be 1 over n. Let's expand this power series. Look at this. N equals start 1. So 1 over 1, x minus 1 and 1. Plus 1 over 2, x minus 1 and square. 1 over 3, x minus 1 cube. So always you have power is right there. That's the coefficient A1. Here is power is 2, coefficient is A2. Power is 3, coefficient is 3, guys. There is a power is 0, constant term, which meaning is A0 is 0, guys, okay? So coefficient related to the power of x, then you're going to find general term right here. Now you understand what the power series is. So for example, this is very simple power series, summation xn n equals 0 to infinity. So expand this power series x0, x1, x2, x cubed. That's x is variable, guys. X is variable. So 0 is the center. And the coefficient Cn is always 1, right? The problem is with this power series, we have to know which x value make this series converge. So let's put this is f of x because that's the function of x. When you plug in the x, you're gonna find some value. When this series function gonna be make sense, if this series converge. So let's say x value is 0, then f of 0, you plug in the 0 is 0, makes sense, right? X is 1.5, then f of 1.5, 1.5, 0, 1.5 square, so on. Another way, summation n equals 0 to infinity 1.5 power n. This is geometric series. We can find the sum. That makes sense, right? But x equal to f of 2 summation n equals 0 to infinity 2n. But this one is 2, 0, 2, 1, 2 square. Oh, this is diverse. So we cannot define this value. Only we can define x equals 1.5, x equals 0. How can find domain of f of x? We call that, so we're gonna find domain of f of x. So we're gonna say radius of convergence. Okay? So I'm gonna introduce radius convergence of power series. Keep in mind, the idea of radius convergence is this power series should be converged when you plug in x value. Another way, we're gonna find the domain of f of x. So then we're gonna decide which value make this power series converge, which x value is power series divergent, okay? So previous slides, we talking about which x value gonna be make this power series convergent, which x value gonna be make power series divergent. So this one is general form of power series, guys. C is center. Center is really important when you're talking about convergent divergent. So whenever you plug in the x value, you define the power series. So power series converge, then this function has meaning. So we want to give the meaning to this function. We want to find domain of f of x. Domain of f of x is the idea of radius convergence, okay? So I'm going to give the formal definition of radius convergence, but this radius convergence related distance from the center. So that's I'm gonna explain how gonna find radius convergence. What's the mean by radius convergence in the next slide, guys. Before we talk about radius convergence, let's leave your absolute value means, okay? Let's start with this meaning. What is the absolute value of 2? So meaning is going to be absolute value of 2 meaning is here is 0, here is 2. You're talking about distance bit from 0. That's going to be 2. That's absolute value means. How about absolute value -2? -2 is right here, guys, right? Distance from the origin, this distance gonna be 2. That's also gonna be 2. So absolute value meaning is distance from the origin. So this one is, another one is absolute value x equals 3, meaning is, what is x value? You find it. Here is the center. Distance from the origin is 3. You're going to 3 here. Another going to left side. This distance gonna be 3. This distance gonna be 3. X value gonna be 3. X value gonna be -3. Guys, make sense? Let's give another example. You see, absolute value x minus 1 equal 2. What is mean by that? So this one is distance. You're going to find the x value, distance from 1. That's the meaning. So here is 1. Distance from the 1 is 2. So you're going to 2 right here. That's going to be 2. 2 right here. That's going to be 2. So what is this by? Go to the right to the 2. That's make 3. Go to the left to 2, that's make -1. So what is the x value gonna be here? -1 and 3. Everyone understand absolute value meaning? So let's do the one more time, guys. Look at this one, other one. So let's practice one is absolute value is +1 equal 2. What is here? This one is 1 is gonna be center. Distance from 1 gonna be 2 and 2. This one is the center gonna be x minus -1, 2. Center gonna be -1. So center is -1. Go to the right 2. 1 and 2. That's gonna be 1. Left to the 2. 1 and 2. That's gonna be -3. So that case, this x value gonna be -3. X is 1. Guys understand absolute value meaning? So now I'm gonna talk about absolute value inequality before we talking about radius convergence. So now we're gonna thinking about this one, guys. Let's thinking about absolute value is less than 1. So this meaning is gonna be center gonna be 0. This represent distance is 1 right here. Another one is -1. This distance less than 1. So what are you talking about here? Okay, so how can write the interval notation is this one is -1 and 1. That's you're gonna find inequality for absolute value. Let's have another example, guys. Absolute value -x minus 1 is less than 2. So first center is, this center is 1, distance is 2, 3, -1. X minus 1 meaning is the distance from the 1 should be less than 2. So less than 2. Distance from 1 is 2 is 3 and -1. But this is less. Here is a less. So we're going to find the x value right here. So what is the interval for this absolute value inequality? That's -1 and 3. Does it make sense? Let's do one more. Absolute value x minus +1 is less than 2. So we're going to find the number line. Center this one is -1. Go to the right. You're going to find the x value whose distance from the -1 is less than 2. So find first is distance going to be 2 first. That's going to be 1. That's going to be -3. -3, 1 is distance from the -1 is 2. So we're going to find the less than 2. So we're talking about this one. X value is inside this one. So what is interval rotation of this? Gonna be -3 and 1. That's how to solve absolute value inequality. Much easy to find solution of absolute value inequality. Now, let's discuss about radius of convergence, okay? Radius of convergence is three possibilities. First is they give the power series. First, you identify center. When you identify center, there are only three possibilities. First one is radius gonna be 0, radius gonna be infinity, radius gonna be 0 and infinity. So only three possibility. So what is mean by radius of 0? Meaning is x equals 0. Only x equals 0, this series converge. Single point. Radius of 0, meaning is, okay, what do you mean by that? X minus c gonna be 0. Distance from the C, center is, you're going to find X value whose distance from center is 0, only 1 point. That's the single point. C is going to be conversion. Absolute value, R is infinity. The meaning is X minus C going to be infinity. X value. You want to find X value whose distance from the center is infinity. So everything, all your number. So which meaning is all three is going to be converse any x value. But the other one is, this one is most important thing is absolute value going to be x minus c is less than r, meaning is you're going to have center. We discussed about absolute value inequality. From here, distance going to be r, distance going to be r. Only this one is, only this x value in here, then c is going to be converse here. Okay, this interval, only x value is here, c is gonna be convergent outside here, then c is gonna be diverse. Inside this interval, c is gonna be converged. So which point have problem, guys? That's, we didn't talk about boundary, which meaning is this x value gonna be c plus r, this x value gonna be c minus r. This endpoint we don't know. Only we know inside x value make c is gonna be converse. Outside this boundary, c is gonna be diverse. But this value, we have no idea. We're gonna talking about later. Let's focus on radius of convergence. Now, what is the big question about radius convergence? How we find it? Guys, how we gonna find radius convergent R? R is a three choice. R is a 0, R is infinity, R is between 0 and infinity. That's only three cases, right? So how gonna find it? We wanna use a ratio test to find it. Okay, that's the key idea. We're gonna using ratio test to find the radius convergent. So I'm gonna give the example here, guys. Really pay attention. How gonna find the radius of convergence? Only three options, okay? Let's find the radius convergence and first one, guys. Let's start with the first one. So I say I'm gonna use ratio test, right? I'm gonna use the ratio test to find the radius convergence. Ratio test say here is gonna be series gonna be this one, whole thing gonna be find general term. So we want to using ratio test here. When you're using ratio test, you're gonna find an is xn. So an plus 1 is xn plus 1. So ratio test say limit L gonna be limit n approach to infinity an plus 1 xn plus 1 over xn right here. So let's simplify. This one gonna be make sense. This one gonna be xn times x. So you're gonna cancel out this one, this. So you have limit n approach to infinity, absolute value x, n approach to infinity, which meaning is there is no n. This is absolute value of x. So what else we have to figure out? We want to know distance from the center. This geometric series center is 0. So this one is what? Ratio test say this L value gonna be should be less than 1. This is convergence. Okay? So you find this one. So conclusion here, absolute value is less than 1. So this one is represent radius from the center. Center is 0, is 1. R should be 1. Everything make sense? So you find the R is 1. Okay, let's do the second one. So really pay attention with me, guys, here. We want to find radius convergence of this one, right? This one. Using the ratio test, here is an m factorial xn, an plus 1, m plus 1 factorial xn plus 1, ratio test say limit and approach to infinity, an plus 1, m plus 1 factorial xn plus 1 over m factorial xn. So first one is this one, simplify. You have limit and approach infinity, m plus 1. Here, this one is cancel out. You have x. So this is x. Now, n approach to infinity, x doesn't have n, so I'm going to put the x is outside. Limit n approach to infinity, n plus 1. Okay, what do you know about here? We are talking about which x value gonna be this limit ratio test, say less than 1, less than 1. But you know this one is going to infinity, getting bigger. Only option you have, this going to infinity, only option here, x is gonna be, only x value gonna be 0. So only one point to make this series gonna be converged. So what is the radius convergent is 0, because only single point you have right now to make this series converge. Let's do more practice for radius convergence. Previous example we did, R is gonna be radius convergent 0, radius convergent to 1, okay? Then we use what? Ratio test to find radius convergence, right? Let's practice another power series. First here, C gonna be an is a whole thing. Then an plus 1, x minus 2, n plus 1 over n plus 1. We're gonna use L'Hopital rule. I'm sorry. Ratio test. L gonna be limit and approach to infinity. An plus 1, x minus 2, n plus 1 over n plus 1 times n over x minus 2n. So when you see this one, what is cancel out first? Here is n plus 1, n. So we have canceled, only one power left. Then you're going to rewrite this limit, x minus 2, n over n plus 1. The limit is about n. We're going to put absolute value x minus 2, limit n approach to infinity n over n plus 1. Where do you go with this limit? This going to 1. So we have absolute value x minus 2. That's the ratio test. So ratio test L gonna be what? Less than 1. So we find the radius of convergence R gonna be 1 because look at this one. X is distant from the center less than 1. That's the radius convergence, okay? Let's do another one. Here is the D this time. What is AN here? AN is gonna be xn over n factorial. AN plus 1 is, here is xn plus 1 over n plus 1 factorial. Okay, so we want to find the ratio test right here. Limit n approach to infinity xn plus 1 over n plus 1 factorial n factorial xn. So this one is show this one is cancel out x n factorial over n plus 1 you have n plus 1. So limit gonna be x over n plus 1 as value x limit and approach to infinity 1 over n plus 1. So this one should be less than 1, but look at this one. This one is what? This limit gonna be 0. No matter what x value, this whole thing gonna be 0, always less than 1, which meaning is gonna be radius convergence. Radius convergence is infinity. So any x value make this is less than 1. Let's review radius convergence. This is a power series general form. Guys, just to summarize the radius convergence. Radius convergence, you're going to use a ratio test. Keep in mind, you're going to using ratio test. So ratio test, you're going to do, I just simplify this form. When you see this one, that's we're going to find it. Then this is the center of the C. We want to find this limit. The first case is R equals 0, meaning is when you're using this one, L is this limit. L, you want to find it, x minus c, limit, and approach to infinity, an plus 1 an. This one is should be less than 1, but this going to infinity. This going to infinity, how make this one is always less than 1? That's R is 0. This x equals c, only one single point. Because x equals c, make this is 0. 0 times infinity should be less than 1. That case, R is 0. Okay? Second case is the same idea, is x minus c, limit and approach to infinity, an plus 1 over an. This might going to 0, then no matter what x value, this always make 1. Any x value make this one is this is gonna be convergence, which meaning is any x value, this whole thing is less than 1. This case gonna be all your number. So this radius convergence infinity. This last case is very popular one. Let's say L is x minus c, limit and approach to infinity an plus over an. The limit exists. So this might be gonna be a, should be less than 1. So we find the radius convergence is 1 over a. So this one gonna be radius of convergence. That's how I summarize how to figure it out. Radius convergence for the infinite power series. Now, previous slides we talking about radius convergence. So when you figured out radius convergence, we really have find interval of convergence. So first one is very simple and easy. Radius convergence is gonna be 0. which actually make a power series is convergence? Only 1 point. So interval of convergence, just 1 point. Radius convergence, x equals center, then make the power series gonna be converged. So that's interval of convergence. Radius convergence gonna be infinity, meaning it's all real number make power series converge. So interval of convergence, negative infinity and positive infinity. Tricky one is radius convergent in 0 and infinity, which meaning is, guys, I'm gonna give the here number line. Here is a center is C. Radius of convergence is gonna be here. Distance gonna be R from the center. This one is R. This one is R. We say this makes series converge. Outside gonna be diverse. What is the problem here? We are not sure about this point and this point. What is this point? Is C minus R. What is this point? C plus R. This point is C plus R. So now what you have to do, we have checked the endpoint. What is endpoint here? C minus R, C plus R. Power series looks like this one. So f of x summation an x minus cn. So we have check endpoint. Endpoint gonna be two endpoint. X equals c minus r, x equals c plus r. So plug in the this is a power series. Here is f, c minus r, summation n equals 0 to infinity an, c minus r minus cn, summation n equals 0 to infinity an minus rn. So you have checked this series converge diverge. Same thing is the other right hand endpoint, right endpoint fc plus r, summation n equals 0 to infinity an, c plus r minus cn. This one is a summation n equals 0 to infinity an rn. So you have to check both power series, you decide. If both are diverse, you're gonna have interval of convergence is open interval both sides. Left endpoint is diverse, right endpoint is converse, then you have left is parentheses, right side gonna be bracket. The other way, this is left endpoint, converse, right is diverse, this one is a bracket, this is gonna be parentheses. Both endpoint is converse, you have bracket both sides. So find the interval of convergence, you have to check it out. Endpoint, check endpoints manually. Okay, don't forget it. You have to check endpoints manually. Let's find the interval of convergence, guys. Previous example, we find all the example here, we already find radius of convergence, okay? First one is radius convergence are gonna be 1. This one is radius convergence of 0. So first case, what do you mean by this one is radius convergence gonna be after value x minus 0 because center is 0, right? So meaning is after value is less than 1, this power series make converge. Here is the number line we're gonna draw here. Center is 0, go to the right is 1. Go to the left is 1, negative 1. This one makes power series is converge. Which one is we have check here? Check is x equal 1. That's the right hand point. X equal negative 1. That's the left hand point. Let's check x equal and you plug in the 1. Summation n equal 1 to infinity 1n. Summation n equal 1 to infinity n 1. 1n is 1. What is mean by this one? 1 plus 1 plus 1 plus 1 plus 1. That's the diverse. Okay, Let's check another endpoint, x equal -1, n equal 1 to infinity, -1 and n. Here is plug in the 1, -1, plug in the 2, -1 square, -1, cube, 4, which meaning is -1, 1, -1, 1. What do you call this one? Diverse. Guys, think about why that's the diverse, guys. Divergent test, okay? So that's, we figured it out. And the point is gonna be make this power series diverse. So interval of convergence, I'm gonna write down the IC from now on. And the point does not include it. Only inside this interval, so -1 and 1. Okay, that's you're gonna find the interval of convergence, okay? Second is gonna be B, radius convergence is 0. What does it mean by that? What is of center, this one? I'm gonna use different color, it's better, guys, right? This center is 0. What is the center? This one is 0. Radius is 0, only 1 point, right? So what is the interval of convergence? This one is only 1 point. That's the 0. Okay, that's you got the idea how gonna find the interval of convergence. Let's do the two more example, guys. Okay, so here is you already find this one is radius convergence gonna be 1. How about this one? Radius convergence gonna be infinity. Let's start with C to find the interval of convergence. So C gonna be radius convergence to 1, meaning its center is true, absolute x minus 2 is less than 1. So number line is center is 2, distance from the 2 gonna be 1, go to the right, 1, I'm sorry, distance from 2 is 1, that's gonna be 3, go to the left, to the 1, that's gonna be 1. So what is the end point here, guys? Is 3 and 1. This one give the inside here is make this power series converse. We have check endpoint. Let's start x equal 1. So x equal you plug in summation n equal 1 to infinity 1 minus 2n over n. Summation n equal 1 to infinity -1 and n over n. Guys, remember that this one is alternating series test. They say this one is gonna be converse. Let's do the other endpoint. This is x equals 3. You plug in the 3, this power series. One n over n. 1n is meaning is 1. What is this harmonic series? That's the diverse. So what is conclusion of interval of converse? You say -1 is gonna make this power series converse. So this one is a blanket. 3 gonna be x equals 3 gonna be diverse right here. Okay, so this gonna be parentheses, not included in the interval of convergence. So now, what is interval of convergence is gonna be 1 is included, so that's gonna be 1. 3 is not included, that's gonna be 3 is parentheses. Okay, let's do the D this time, okay? D gonna be, this is radius of convergence infinity. So this series has a center is 0. So x value make this series gonna be converse is infinity. So which meaning is here is a 0, distance from the 0 is infinity. So that's talking about all your number right there. Okay? All real number meaning is you write the interval rotation is gonna be negative infinity to the positive infinity. So this gonna be interval of convergence. So now you guys understand how you can find the radius convergence, how gonna find interval of convergence. You have to make sure using the ratio test find the radius convergence. Then you check it out endpoint to find the interval of convergence.